Hello friends, I welcome you in lecture number 2 on set theory. In this lecture we will discuss about inclusion and equality of sets. So first we understand what is meaning of inclusion. So first we recall this definition: subset of a given set. So as we know, if we have two sets A and B, and if every element of A is also an element of set B, then we say that the set A is a subset of set B. Another word for this is we can say that set A is included in the set B. So that is the meaning of inclusion. A is included in the set B, or equivalently A is a subset of set B. So here we have written the definition: let A and B be any two sets if every element of A is an element of B, then A is called a subset of B, or A is said to be included in set B, or we can say that set B includes set A. So if A is a subset of B or A is included in B, we are using this notation: A is subset of B or A is included in B, or we can use this one also: B includes A. Either B includes A or A is included in B, both are the equivalent things. So this is meaning of inclusion. If every element of one set is an element of another set, then we say that A is included in B, or B includes set A, or A is a subset of set B. So now we have discussed in the previous lecture that if some element A is present in a set E, then we are using this notation. This notation means that A is a member or A is an element of set A. If A is not an element of set A, we are using this notation. So this notation is for membership of A in A, and for subset we are using this notation: A is subset of B. So we should understand the difference between membership and inclusion. This is membership notation, this is inclusion notation. So we just distinguish them with the help of example. Suppose we consider these four sets. Suppose set A is a set containing three elements 1 to 3, B contains two elements 1 and 2, C contains two elements 1 and 3, and D contains only one element 3. So here we can see 1 and 2 are elements of B and they are elements of A also. So B is included in set A, or B is a subset of set A. Similarly, every element of set C is also an element of set A. So C is a subset of A, or C is included in A. And D has only one element 3, which is also present in set A. So we have D is subset of A. Also we can see that D is subset of C also, because this 3 is present in C. And D is not a subset of B, because D has element 3, which is not an element of B. So D is not included in the set B. So now here we have written that 1 is a member of this set, which is set capital A. So 1 is a member of this set A, but 1 is not included in A. So we cannot write this notation for 1. We cannot write that 1 is a subset of 1, 2, 3. This inclusion notation is only for sets. So if 1 is a member of set A, we will use this membership notation, that is belongs to. But if we are using this notation, then it is not correct. So this statement is false, that 1 is subset of 1, 2, 3. And if we use this notation, now this is a set containing element 1 and this is a set containing element 1 2 3. So now this is proper notation because now we are having two sets. So this inclusion is a notation between two sets, and this belongs to is a notation between member and set. So we can write 1 belongs to 1 2 3, but we cannot write one subset of 1 2 3. Similarly, we can write that set containing 2 is a subset of set containing 1 2. But if we are writing 2 is subset of 1 2, then this is not correct. Okay, because 2 is a member of 1 2, but set containing 2 is a subset of set containing 1 and 2. So here we have mentioned that only a set can be included in or can be a subset of another set. So definition of subset is for two sets. So only a set can be a subset of another set. Element can never be a subset of another set. And while only elements can be members of a set. So if we are considering that 1 belongs to 1 2 3, then this is not correct because here we have membership notation. This is a set containing 1, so this is not correct. Instead of that, we should write 1 belongs to 1 2 3. So this one is correct. Here this is a set containing 1 and it is not present in this set, so we cannot use membership notation here. Instead of that, if we want to correct this, we should use inclusion notation, then it becomes correct. So we should take care of these little things. Suppose we have this type of sets. Here we have set containing 1, and on this side also we have set containing 1, set containing 2 and element 3. And if we use membership notation, then this is correct because now set containing 1 is a member of this set. This set on the right hand side contains set containing 1. So here we should use membership notation. Here we cannot use this notation because now this set is a member of this set on the right hand side. So we cannot use inclusion notation here. If we want to use inclusion notation, then here we should consider set containing set 1. If we want to use inclusion notation, then here we should, on the left hand side, we should consider set containing 1. So now here this set contains set containing 1, and this set on the right hand side also contains this set. So this element is present in this set also. That means this is a subset of this set. So these are very easy things, but we should take care of them properly. So it is clear that only a set can be included in another set, or only a set can be subset of another set, while only elements can be members of a set. We consider another example. As we discuss, our set may include other sets as its members also. For example, here we have taken this set capital A, whose members are these elements 2 and 3, and another element is set containing 1. So A is a set which contains another set as its member. So here 1 is a member of A, but 1 is not a subset of A. If I am writing that 1 is subset of A, then this is not correct, because now set containing 1 is a member of set A. we can write in this way that set containing 1 is a subset of A, because now this member is a member of this set and it is present in this set A also. So this set is a subset of set A. So be careful here also that every element of this set has only one element, which is set containing 1, is also present in this set A. Therefore, this set is a subset of set A. Similarly, if we consider this set, then it has two elements, set containing 1 and element 2. Both are present in set A. So every element of this set is an element of set A. Therefore, this set is a subset of A. 2 belongs to A, that is obvious. 2 is a member of set A. And set containing 2, 3 is a subset of set A, because set A includes both of these elements. Now we can list properties of set inclusion. So these are obvious properties. For any set A is subset of A, because every element of A is also an element of A. Therefore, A is a subset of A. Similarly, if we have 3 sets A, B and C, then if A is subset of B and B is subset of C, then A is always a subset of C. So this first property is known as reflexive property, and this second property is known as transitive property. So we will talk about these properties in detail in the topic of relations whenever we will start. So recently we will just assume these properties. They are obvious. For any set A is included in itself, and if we have 3 sets A, B and C, and if A is included in B and B is included in C, then A is always included in C. Another definition is equality of two sets. So if we want to talk about equality of two sets, then suppose we have two sets A and B. So A and B are said to be equal if A is subset of B and B is subset of A. That is, if A is included in B and B is included in A, then A and B are called equal sets. So two sets A and B are said to be equal if and only if A is subset of B and B is subset of A. Or in other notation we can write in this way also: A equal to B double implies A is subset of B and B is subset of A. That is, if A equal to B, then this is true, and if A is subset of B and B is subset of A, implies A equal to B. So here we have written several sets which are equal. Here we have set containing 1, 2, 4. Here we have set containing 1, 2, 2, 4. So repetition of elements is allowed in the representation of set. Here 2 is repeated 2 times. So these two sets are equal because every element of this set is present in this set, and every element of this set is also an element of this set. If we consider these two sets as A and B, then here A is subset of B and B is subset of A. Therefore A and B are equal. And order of elements is also not important whenever we are writing a set. So here we have 1, 4, 2, here 1, 2, 4. But for equality, what we have to take care is every element of this set is present in this set, and every element of this set is also present in this set. So these two sets are also equal. Suppose I have this set capital P equal to set containing 1, 2 and element 4, and capital Q equal to set containing 1, 2 and 4. Then here P and Q are not equal, because we can say that the set containing 1, 2 is present in P, but set containing 1, 2 is not present in Q. So every element of set P is not an element of set Q. So therefore P is not a subset of Q, and therefore P and Q are not equal. Or we can see that here 2 is present in Q, but 2 is not present in P. So therefore Q is also not a subset of P. So therefore P and Q are not equal. So if we want to show that two sets are not equal, we have to show that either P is not a subset of Q or Q is not a subset of P. So here 1, 2 is present in P, but 1, 2 set containing 1, 2 is not present in Q. Therefore P is not a subset of Q, and therefore P and Q are not equal. Similarly, here on the left hand side we have set containing set, and here we have set containing 1. So these two are also not equal, because if we want to check that this is a subset of this set, then we must have this element, which is an element of set on left hand side. This element must be a member of the set on the right hand side, which is 1, but this is not true, okay, because this is a set, this is a set. So we cannot say that this set is a subset of this set. So therefore they are not equal. And if we concentrate on the other side, or we can understand, suppose I consider A equal to set containing 1 and B equal to set containing 1, and this A is set containing 1. So we can see set containing 1 is a member of A, but set containing 1 is not a member of B. Therefore A is not a subset of B, and therefore A and B are not equal. So in this way we can decide whether two sets are equal or not. We can check on other side also. Here 1 is a member of B, but 1 is not a member of A, because A is a set containing 1. A does not contain the element 1. Therefore B is also not a subset of A. Therefore A and B are not equal. But it is enough to show that one set is not a subset of another set to show that two sets are not equal. So this is enough to prove that A is not equal to B. Okay, so either we should show that A is not a subset of B, or B is not a subset of A. So either we can use this one also. 1 belongs to B, but 1 is not in A. Therefore B is not a subset of A. Therefore A is not equal to B. So either we should write this one or this one. No need to write both the justifications. To show that two sets are not equal, it is enough to show that one set is not a subset of another set. If we consider these two sets, set A is those elements x which are solution of this equation, x into x minus 1 equal to 0, and set B is set containing 0, 1. Now to write down the elements of set A, first we find out solution of this equation. So this implies either x is 0 or x minus 1 is 0. So x is 0, another possibility is x equal to 1. So set A is also set containing 0 and 1. So it is obvious that A is a subset of B and B is a subset of A. So therefore A and B are equal. There are only two elements, 0 and 1. This is another example of equal sets. This set contains 1, 3, 5 and so on. There are infinite number of elements. Next element is 7, then 9, and here we are considering those x which are odd positive integer. So we know that odd positive integers are nothing but 1, 3, 5, 7 and so on. So here also, if we consider this set as A, this set as B, then we can see that A is subset of B and B is subset of A. Therefore A and B are equal. So in this way we can decide the equality of two sets by just checking that A and B are subsets of each other. Another definition is proper subset. So a set A is called a proper subset of another set B if A is a subset of B but A and B are not equal. And to show that A is a proper subset of B, we will use this notation. We will not use this equality sign in proper inclusion. So this is notation for proper subset. A is a subset of B, and this is also known as proper inclusion. This notation is called proper inclusion, and this notation is simply known as inclusion. So definition is simple. We have to take care that A is subset of B and A and B are not equal. So if A is subset of B, then B is not a subset of A. Otherwise A and B will be equal. So this is the example for proper subset. Suppose A is a set containing 1, 2 and B is a set containing 1, 2, 3, 4. Then we can see every element of A is an element of B. So therefore A is a subset of B. But 3 and 4 are not present in A. So B is not a subset of A. So if B is not a subset of A, then A and B are different. So A is not equal to B. Therefore A is a proper subset of B. We consider one more example. Set A is this set of odd positive integers that we just have written. Odd positive integers means 1, 3, 5, 7 and so on. Infinite number of elements. And B is this set of integers. So set of integer includes all odd positive integers. So here also A is subset of B. Now B is Z. So every element of Z is not an element of A. For example, 2 is an integer. So 2 belongs to Z. But 2 is not an odd positive integer. So 2 is not in A. So B is not a subset of A. And therefore A and B are not equal. So it is clear that A is subset of B and A and B are not equal. Therefore A is a proper subset of B. So A is a proper subset of B if A is subset of B and A is not equal to B. Now we know that A and B are equal if and only if A is subset of B and B is subset of A. Now for proper subset, A is subset of B is required. So A and B are not equal if B is not a subset of A. So we can understand in this way also, A is a proper subset of B if A is subset of B and B is not a subset of A. So in this lecture we have discussed about inclusion and equality of sets. So this was very easy concept. Inclusion means every element of A is an element of B, that is A is a subset of B. And equality means A equal to B if and only if A and B are subsets of each other. So this is all about this session. I hope you like it. Thank you very much.